It is a pleasure to be here. I am Monroe Weber Shirk, and I'm very happy if you call me Monroe. I'm very comfortable with that. I taught at Cornell University for many years and developed the Agua Clara program there, and in partnership with a partner organization in Honduras, Agua para el Pueblo. I first taught like the very early precursor of this course in 2004, and I'm realizing that by the time scales that you are all used to, that is a very long time ago. It means that you're thinking, oh no, we're gonna listen to lectures that this guy has given 17 times and it's gonna be awful. But the good news is that we're working in a field where there is a lot of change. And so there's hardly anything, or perhaps absolutely nothing, that's in my notes now that was in my notes in those first years. And there's been a gradual replacement of things that are in those notes as we learn about how to treat water for communities that don't have a lot of resources. So anyway, that's me. I'm Monroe. I've been working on drinking water treatment for a very long time, and I'm super excited about this opportunity. So we're going to begin with, I've got a number of slides just to get us like the context for this course. And then we'll have a time a little bit later on today to introduce each other or introduce ourselves so that we begin to get to know each other. And I'm hoping that I can time this, that we will all end up in the space where we do office hours so that you can learn where that's at, so that if you have questions, you can know how to actually grab a virtual meeting with me very easily. So here's the outline. We're going to go this step by step. So what's this course about? We'll start there. So this is about creating new solutions. So it's about creative thinking and about this particular problem of how in the world can we provide safe water to all the communities that don't currently have safe water on tap. And we're going to challenge the myth that this task can be accomplished by applying traditional technologies. And we will identify opportunities for new insights. We'll be talking about this new field of sustainable drinking water treatment and the technologies that go with it. And underlying this is a bunch of assumptions. One is that we do need engineers to help create better solutions so that resource poor communities can have access to safe drinking water. And another hypothesis is that there are new things yet to be invented that would make this better. So we're not at the end of the road. There's more to learn in environmental engineering. And we will practice design thinking, and we'll talk more about that sometime. Once we have gone through a couple design challenges, we'll talk a little bit about design thinking. It's a whole approach to how you design things so that they can actually work in the real world. And this is the course summary in a t-shirt done very, very quickly. So it's about flocculation, sedimentation, filtration, and annihilation, i.e. disinfection. So that's the course topics. There'll be some more things that will come in there that help make these things work. So my goal is that we provide, all of us provide a safe learning environment where a bunch of things can happen, where each of you can develop a fundamental understanding of the processes that control the performance of each of the drinking water treatment steps, and hence how you can design them to be as good as possible. And so that each of you experiences the power of using constraints and physics and this goal of sustainability to guide the design of infrastructure. So not just think about design as a simple homework problem, but think about it in the context of the real world and how real constraints, including things like what's actually available in the market, what can you buy at a hardware store, and how do you use that to help guide your design. This course is part of the Agua Clara ecosystem, and that ecosystem has been designed for innovation and collaboration. So there's Agua Clara Reach. I didn't share this, but I am the technical director for Agua Clara Reach, which is a nonprofit organization that provides technical support and designs for partners who are building the water treatment plants that we are designing. So there are volunteers that help out with Agua Clara Reach. And then there's this cool part where you come in. There's university research and there's university programs that are created so that people are learning about these new technologies and helping to create better technologies. So that's happening at Ohio State University, at New Jersey Institute of Technology, and at Cornell. And we call that the RIDE program. RIDE stands for Research, Invent, Design, Empower. So 4 cool words: research, invent, design, empower. But that's not enough to actually get things done in the real world. We also work with partners who are out in the rest of the world and who are the ones that can build the water treatment plants. So there's several of them: Gran Vicas, Agua para el Pueblo, who are the implementation partners. We provide them with designs and technical support and best practices. They provide us with insights and problems that then help guide the design. So there's new ideas coming from research partners. There's problems coming from the field. And Agua Clara Reach kind of mediates those conversations and helps create better designs. And we just had a lovely experience working on that this morning. And then the partners, see, we still didn't get anything on the ground yet. The partners work with communities to build the plants so that communities can have a water treatment plant and get safe water on tap. And so that's where it finally hits the real world fully, is where a plant gets built for a community. And then there's more pieces to this, and you could keep on adding more connections because every member in this organization has other connections that end up mattering or being important. So the implementation partners have to figure out where the money comes from to build these plants. So there's, and the regulatory environment for building a water treatment plant in a country. So the water ministry is involved. There might be development banks that are helping to fund it. There may be bilateral donors involved. And I could go on, making this web more and more complicated, but that's enough to give you a sense of where this course fits, which is inside that piece of the university program and helping to support ultimately university research. My expectations, and we can evolve this as we think about all of this, but my expectations are that you come to class ready to learn, that you share your video if possible. And I recognize that there are times when you can't, but if you can, I really like that. I really like being able to see you and hopefully recognize when you're giving me the "I don't understand this" look. You may have to maybe exaggerate that a little bit so I catch it. We are learning with you. I am in the process of updating the lecture notes because we continue to learn about water treatment. The assignments for this year are all completely new. And the reason for that is we are using better tools. I'll talk a little bit more about that later. And that means that you will undoubtedly discover something that doesn't work as you expected. So you'll be starting an assignment and you're like, what did Monroe mean in question 2? It makes no sense to me. So when that happens, you could either get really frustrated and angry at Monroe for not being clear, or you could recognize that Monroe is also a human and he might have messed up. And so talk to me. So it would be just crazy luck if you didn't ever feel frustrated in this course, right? You're going to feel frustrated at some point, and the question is, what do you do with it? So my request is, come to us, send Patrick and Claire and me an email saying what you found. We're trying to learn new things, all of us. We're trying to learn new things, and the question is, how do you learn? I'm wondering if you could think for a second, when was the time in your life when you think you might have been learning like fast? So one of the insights is you will play much better, you will learn much better if you can work on it. Sorry, you can play with the assignment when there's still time in reserve, when you're not feeling a huge time crunch. Because once you start feeling the time crunch, the joy of play goes out and your ability to learn goes down. Which is why we have a system where we require that you submit a draft 2 days before it's due. And we expect that it's like half done by then, just to make sure that you've played before the assignment is actually due. So that's why drafts and final submissions and teams, so that you have others to play with, and so that you can learn faster, because you can talk to other team members and say, hey, how did you do this? And you can figure things out faster together. Claire will be having office hours, and I will be there as well. So Claire will be there to help you, and hopefully you feel comfortable coming to either one of us. And we're going to be doing it in Onshape. And so now you're probably wondering about Onshape. I have a question. Did any of you ever use Onshape? Anyone? Okay, we're all starting out right at the beginning, okay? So it's a flat playing field. You all have exactly the same advantage. And you're gonna learn this new software program. And I'm realizing that this is a change from when we first began creating the syllabus for this course. Initially, we thought we would be using Python. And then over the last half year, we realized, wait, there's a much better tool that just allows us to do so much more in engineering. So we're using Onshape. Onshape is the fastest growing CAD program as far as user base. So it's growing really, really fast. It is completely online. It is completely free. So you can use it for anything that you want. You don't need any special hardware. You can, as long as you have a computer that can support a browser, you can do CAD work. So no expensive computers needed. And this has been our evolution. We started years ago with MathCAD, which handles units nicely, and we linked that to AutoCAD. So we wrote code in MathCAD that would in turn create code that we could pop into the command line of AutoCAD and have AutoCAD draw things. And that was, I thought it was awesome, but in retrospect, it was a pain to maintain. Then we switched to Python and we began looking for a different CAD environment. We liked Python because it's open source. And it also handles units elegantly, but there was no easy way to integrate that with 3D modeling. And so Onshape finally pulls things together. So Onshape can handle units well. It allows us to integrate hydraulic design, like process design, with the 3D model, the actual sketches and 3D model of the thing that we're creating. And so that's the platform that I want you to learn into. It's a tool that I wish I had 20 years ago, but now we have it. And so let's learn how to use it.